So functional dependency, it is the formal design guideline. So as you already learned about informal design guidelines, guideline 1 tells what? Semantic of the attributes and relation must be clear. And second guideline, what it tells? You have to avoid from anomalies, update anomalies. Those anomalies are we call as a problems, and those problem arises when if you are trying to join the any two entity types or the relationship types as a single relation. So avoid combining the multiple entity types and the relationship types as a single relation. So what are the entity types you are having? That one you take as a one relation. So then you can prevent from those anomalies. That is what we tell as a guideline 2, that is informal design guideline. And the third in informal design guideline, what it tells, you prevent from anomalies. Okay, sorry, null values. So as you already know that, so frequently what are the attribute values you are required. So for that one, frequently if you get the null values, more number of null values for that attribute it holds, then it okay, your wastage of the memory space only. Null values don't have the any meaning, so you have to avoid by such type of the problems. So avoid the null values here. Okay, in exceptional cases, for 10% of the attribute values you may get the null values. It is exceptional case. In that situation you can go and use the null values, otherwise don't go and use the null values for the attributes. That is your third guideline. And fourth guideline, what it tells, whenever you want to join any two tables, for joining that compulsory how to specify the joining condition. Without joining condition, if you are joined any two relation, then you will get the problem, that is what we call as a spurious tuples, that is unwanted tuples. Okay, so unwanted tuples problem, if it arises, then it creates the okay problems. That's why you avoid from the such type of the tuples also. How you can avoid? By joining with the condition here. So these are the four guidelines, and these four guidelines we call as the informal design guidelines here. Now we'll go and learn about the formal design guidelines if you want to design any database. So in that first one we call as a functional dependencies. It's the tool, it's a formal tool for analysis of relational schemas. Okay, functional dependency is the tool which is used for making analysis of relational schema, and it also identify and also describe the problems. What are the problems we are okay already discussed? That one we call as a update anomalies. It detects those anomalies if you take the help of this functional dependency. Let's see about the functional dependency here. Functional dependency. So what actually functional dependency? It is one type of the constraints it between two sets of attributes from the database. In the database, you are taking the two set of the attributes, and for those attributes you are specifying some constraint. According to that constraint, if you are insert the tuples, then you can avoid from such type of the anomalies here. So then let's see what actually functional dependency means. Definition is, it is denoted by x arrow mark y. X determines y. This one we read as x determines y. If you want to read like this, or from this side if you want to read, then we call that is what? Y functionally dependent on x here. Okay, so from rightmost if you want to read, so from right side if you call that is what? Y is functionally dependent on x. In the same way, if you want to read from this left side, that is what? X determines y here. What it tells, it is between two sets of attributes x and y. X is one set of attributes and y is another set of attributes that are subsets of R. R is what here? It is a relation, and here you are specifying the constraints, that is what we call, that is the relational state R of R. Relational state means what? At present in that relation, how many instances you are having, all those instances are valid state. If it is in the valid state, then you take that one as a relation state, small r as a relational instance of a capital R as your relation. Okay. Here constraint is what? T1 and T2 are two tuples in a relational state. So that tells what it is. In two, okay, T1 and T2, X attributes values if it is same, they must also have T1Y equal to T2Y. It's very simple. In two tuples, X attributes values if it is same, then compulsory Y value must be same. If it is same, then you call that is what? X determines Y, or Y is functionally dependent on X. For example, I'll take one example here. Assume that this is your one relation and I'll take the attributes as a name, okay, and SSN here, okay. So this is your relation, name and the SSN, and I'll give the name as a, okay, R1, and SSN for this one is 1 here, and second is R2, and I'll give the SSN as a 1 2 here, okay. So now this is your T1 tuple and this is your T2 tuple here, and I'll take this as a X attribute and this as a Y attribute. Now I'm taking only single attribute. In the same way you can also take the set of attributes as a X and set of attributes as a Y here. So now for example, if I take this two as a two relations in two tuples, okay, if X value if it is same and Y value must be same here. So if I take this one, that is T1 attribute value, it is what it is, T1X if it is equal to T2X here, okay. So then what is the thing here? I'll assume that I'll take one more tuple, that is, okay, R, and I'll take as a 1 here, okay, and this one I'll take as a T3 here, and I'll check that one here, T3 it is, okay. So X value what it is I am having here, that is X value is R1 in T1 tuple, and also X value I am hanging as a R1, okay, in T3 tuple. This is your T3 and this is your T, and I am taking this was a X here, R1 and R1. Yes, if it is true, then compulsory T2Y, T1Y, T1Y value it is what it is, 11 it is, okay. T1Y must be equal to what here? T2Y here. So T2Y, sorry, T3Y, okay. So T3Y is also what it is? It is 11 here. So in T1 and T3, X value if it is same, then compulsory Y value must be same. If it is same, then you call that as what it is? X determines Y, or Y is functionally dependent on X here. So now you may have the question, why we go for this one here? It's very simple. So this one, if you know the X value, with the help of this X attribute, you can determine what the Y values are there. So this is very simple. If I know your USN number, with the help of that USN number, I can extract remaining all attribute values of that particular tuple. Okay. So now that is when it is possible. So if it is possible, if you are having this condition is true here, okay, in two tuples X and Y, okay, X value if it is same and Y value if it is same, then only it is possible, then only you call that one as a X determines Y here. So for example, here only I'll take the X, okay, X as a name and Y as a okay, X as a USN and Y as a name, address and USN, okay. So if I know your USN number, with the help of USN number, yes, I can know, okay, what is the name of the student and what is the address and what is the branch here. So then this is the true here. For example, if I take X as a branch here, if I know branch, with the help of the branch, is it possible to identify the each individual student? Is it possible or not? You unmute yourself, you can tell. If I know the branch, so I'll tell that is, I know one of my friend, and that friend branch I know, so I want to meet that friend. I want the name of the friend and address of the friend here. Is it possible with the help of the branch name getting that particular individual student name and address? Are you there or not? Is it possible? If I know only the name and the, only the branch of the student. With the help of the branch, student information, name and address of the each individual student, it is not possible here. I'll tell that as what ISC student, I want my friend name and address. I know just he is studying, okay, he or she is studying in ISC. Then is it possible to get individuals to your friend name and address? No. All the students who were studying in the ISC department, all student name and address you can get, but individual your friend information, no, it is not possible here. In the place of that one, if I tell that is what, I know the USN number. This is the USN number of my friend. Then is it possible to get the name and address of that particular student? Yes, it is possible. So that is what we call as a X determines Y. Means what it is? Y is the remaining information related to student. I know the USN number. With the help of the USN number, yes, it is possible to get the address, name, phone number, all those things here. So that is the what we call as a functional dependency. When it is possible, while designing, you check this criteria. In this, okay, that's why here I am taking the two tuples, because in T1 X value, that is if I take as a branch as a ISC, okay, so then in T2 also I'll get the branch as a ISC only. So now for example, if I take the name, so for one student I'll get the name as a R1, for another student I'll get the name as a R2. Is it equal now? T1 having the Y value as a R1 and T2 having the Y value as a R2, because names are different here. So then this functional dependency doesn't work if I take the X as a branch here. In the place of this one, if I take the USN number, as you know that USN number in two tuples, if I take the same USN number, this number always represents only one student, that is the R1 only. How many types if you want to take? Yes, you can take. Wherever you get the USN number, for that USN number always you will get the, okay, name as a R1 only. Then only you call that as what it is this, okay, X determines Y, that is USN determines name, address, all those things here, okay. So or this name, address are functionally dependent on USN number. So this is what we call as a functional dependency, and this is what we call as a constraint. Constraint means what it is? Compulsory. If USN number, if you are written as a 1 here, compulsory for Y, or every time you have to take as a R1 only. By mistake if you are enter as a R2, it gives the error message because it's the constraint here, okay. So that is the, okay, what we call as a functional dependency. So it legal relational states, okay, if I take the any of the relational states, it must compulsory satisfy the functional dependency constraints here. So once if you are design the any of the database, so for that that one you call as a legal relational state when if you are satisfied this functional dependency constraint. As I told here, now I created the database as a student. Now whenever I enter the values for the student, informations for the student table, so that one we call as a relational states, and according to condition if you are entered, then you call that one as a legal relational states here. So next is when you can go for the functional dependency holds and when if it does not holds. As I told earlier, if I take the name, so USN number, then it holds the functional dependency. If I take the branch, then it doesn't hold the functional dependency. That's why you have to check which are the attributes you have to take and which are the things you have to decide as a X. Okay, attributes group set is now your rank. I created the student and I also decided that in the student I want SSN, name, okay, branch, address, mobile number, all those things. Now you have to decide that, so whether all the remaining attributes are depends on name or whether it depends on address or whether it is depends on USN, like that you have to verify. That verification only we call as a functional dependency. After after verification you will get to know that S with the help of USN, remaining all are dependent here. Okay, so because USN is what it is, unique. So by that I can identify each individual tuple. So remaining whatever the attribute values are there, all those attribute values I can get automatically if I know the USN number. So then USN number is your X and remaining all the attributes are your Y here. Okay, and all are functionally dependent on X. Okay, that is the USN number. That is one constraint as a formal design guideline. And next one, you are going for learning about the different normal forms. These normal forms are based on primary keys. Yes, that primary key already know that primary key means what it is, which attribute holds unique value, that attribute actually we call as a primary key. So based on that primary key you will learn about different normal forms here. That is what you call as a normalization process here. Normalization process means you will learn about the different normal forms, and in every normal form you will learn about the different constraints. If it is satisfied the first normal form, then you will have to move for the second normal form. If it satisfied the second normal form, then third normal form, like that. Why we go for this normalization process? Okay, so it is the relational schema design. If you want to go, or if you want to design your own relational schema, then normalization process is very important, and that is for which purpose it helps to perform a conceptual schema design using a conceptual model, then map conceptual design into a set of relations. In relational schema design, first you have to identify what are entities, what are the entity types, what are the relationship types, and what are the constraints comes under in relationship types. All those things you have to understand first. If you perform those steps, then you can map that one as a relation and design relations based on the external knowledge derived from existing implementation of files or forms or reports here. So next you have to decide the or design the relation that is based on your previous knowledge. As you already know that you know the traditional file system formats, and with the help of that file formats or forms and reports, that is the knowledge you require to if you want to design the relations here. For designing the relations schema, okay, what are the knowledge you require? You require the conceptual designing first, and you have to map with the relation, and also you know the procedure of how actually these relations are required to store. So if you know the concept of files and forms and reports, any one among these three, so then you can design the relations, okay, based on this knowledges here. Normalization of relation. Okay, it takes a relation schema through a series of tests here. As I told, normalization process is what it is. It is once again you have to make the test the things. Okay, once if you are identify the relation schema, next you have to follow the some series of tests. That is what we call as a normalization process here. It certifies that process. It certifies what here, whether it satisfies a certain normal form or not, and it proceeds in a top down fashion. Okay, top to bottom, top to down fashion you are taking here. So as I told earlier, so first normalization process, if it is satisfied, then it prove that yes, you can go for the second normal form. So in the second normal form also you are performing some test, and if it is satisfied that one, then you go for the third normal form. Like that, in the normalization you are having the different normal forms. So each normal form it satisfied the certain condition, then you can move for the second one here. Normal form test. So what test it performs here? That is what we call as a normal form. As a definition, it is a normal form of a relation refers to the highest normal form condition that it meets, hence indicates the degree to which it has been normalized. So highest degree, as I told earlier, first, second, third. So if your relational schema, if it is okay, pass the all the three tests. Passing is nothing but if it's satisfied and if it fulfill the all the constraints, then what is the highest normal form you'll get? No. So that relation, if it refers the highest normal form, then you call that one as having the good relation. That means the indicates the degree level of that one. So if I design and if I fulfill only the first normal form and it fails in the second normal form, then it tells it is what it is not a good designing here. So if you are design a relation and if you try to, okay, clear that particular test also or conditions, okay, normal forms are nothing but the constraints. Second normal conditions also you try to redesign. So if you are redesign like that, if you are meet the highest normal form, then your relation design is the good relation. So now you may have the question why we go for the relation normalization. So now for making the normalization, here you have to follow the two properties here. One is the non-additive join property and next one is the dependence preservation property here. As I told earlier, so normal forms, first normal form if it is fulfilled, second normal form if it is not fulfilled, then you have to redesign. While redesigning, there may be chances of combining the multiple, okay, two relations as a single relation, or you can divide the single relation as a multiple relation due to this condition. If it not satisfy the second normal form, then what is the thing? You have to go for redesigning. Here redesigning is nothing but you divide that single relation as a multiple relation, or you can join the two relation as a single relation because it doesn't pass those normal tests here. So if you want to fulfill those tests or if you want to pass those normal forms, one thing you remember, you have to check whether it is non-additive joint property or not. Non-additive joint property means what it is? If you are join the two relation, after joining those two relation, so what are the tuples you'll get? No, those tuples are remain as it is. You won't get any additional informations along with that. That is what we call as a non-additive join property. Non-additive join means what it is? If you are joined any two relation, in each relation what are the tuples you are having? So those tuples will get as it is. You won't get any additional tuples. So that is what we call as a non-additive join property. Next is the dependency preservation property. So it desirable but sometimes sacrificed for other factors. Dependency preservation property, as I told, okay, functional dependencies. Okay, if I take the okay, x, y is functionally dependent on x. Okay, then you have to check that while dividing the any relation as a multiple relation, or if you want to join the multiple relation as a single relation because it not pass the any of the normal form test. So in that situation, whether the dependency is preserved or not here, that one also you have to check here. So if it is dependency preservation property and non-additive join property, if both are satisfied, then only you can divide the relation as a multiple relation, or you can join the multiple relation as a single relation. When you will go for those things, if it is not satisfied the any of the normal forms here. So these two properties are very important, and these things also you have to check along with the normalization process. So practical use of normal forms. So what I just in general I told, no, resulting designs are of high quality. Why we go for normalization? Where actually it is required. So if your normalization is carried out in practice, so if you are designing the any of the database, so for that database designing, so if you go for the functional requirements. Once if your functional requirement is completed, next you have to design your own database. For designing that normalization process, if it is carried out, then from that what are the designing you will get, note that resulting designs are of high quality. and it meets the desirable properties as stated previously. And also it okay, desirable properties are what here? Non-additive and the dependency preservation, and the normal forms are specified at degrees. Higher normal forms, if it is satisfied, then you will get the good quality of the designing here. So usually, as I told earlier, so what is the normalization? What is the high quality here? So it is particularly how to pay the attention for normalization up to 3NF or BCNF or at most 4NF. As I told earlier, in the normal forms, you will learn about the different normal forms. First normal form, second normal form, third normal form, Boyce code normal form, fourth normal form, and fifth normal form here. If you want to design any of the database, so here maximum attention you have to give where if you want the high quality designing result. High quality designing result if you want, then maximum limit, okay, normalization process you have to go for up to what? Third or BCNF. At most maximum it is 4, but in general usually for almost all relations it comes under in this 3NF and BCNF. These two, if it is satisfied, then you can consider that one as a high quality designing here. Okay, next, do not need to normalize to the highest possible normal forms. As I told earlier, you are having the fourth normal form and fifth normal form also, but here thing is what? It is enough. If you want the high quality, so third enough and BC enough is enough here. Okay. So next is the denormalization. It is the process of storing the join of higher normal form relation as a base relation, which is in a lower normal form here. It is reverse here. Okay, denormalization as it is what it is. It is reverse of the normalization. As I told earlier, so if you are storing the process of joining higher normal form relation as a base relation. So if you are go for fourth normal form or fifth normal form, no, then what are the output you will get? No, that designing is having the higher normal forms, but it is in the lower normal form we will consider, which is in a lower normal form. That's why usually for any of the database designing, high quality limitation is up to 3NF and BCNF, because this fourth and fifth normal form if you go no, then it lowers the your quality. Why? I'll explain during that normal forms. Next is, you already know these things, that's why I'll explain this part and afterwards I'll stop. Definition of keys and attributes participating in the key. You already know that what is super key and what is the key. Super key is what it is, set of keys. So in that you are having the primary key, okay, secondary key, all those things, okay, group of keys. If I take, okay, now I am designing, I don't know which one is the primary key, then I'll make as a super key. That super key is what it is. So it is having the set of keys. It may be name, I'll make the group of these keys, name, SSN, okay, as a one group, and I'll call this one as a super key, and in this one SSN is the primary key and name is the candidate key here. Okay, all these things you already learned in relational design, same thing it is explained here. An attribute of a relation schema R is called a prime attribute of R if it is a member of some candidate key of R here. So now here one thing you remember, you are using two more terms, that is prime attributes and non-prime attributes. So prime attributes are what it is the member of the candidate key of R here. So if I take as a SSN, all these are what now it is, name and address as a three keys here. This group I can take as a one super key here. So now this SSN, name and address individually I can call as a candidate key here. So if I take as a name, name is what it is the member of the candidate key. This one I can call as a prime attribute. SSN is the candidate key. This one also I can call as a prime attribute. If I take the phone number as a mobile number here, is it member of this candidate key? No. Then it is what? Phone is the non-prime attribute. Okay. So if the attributes are the members of the candidate key, then you call that one as a prime attribute. If it is not a member, then you call that one as a non-prime attribute. These are the two more terms comes under in this normalization. Is that clear now? Prime attributes, it is candidate or member of a candidate key. Non-prime attributes, it is not a member of a candidate key. Okay. So this is about your this one. And one more thing, you already know that if you take the any of the relation, all the attribute must be atomic indivisible here. This thing is very important. Okay. What are the attributes you are having now? All those attributes must be atomic. Atomic means what it is? It doesn't support composite and multi-valued attributes type. Okay, multi-valued attribute types means what? For the same attribute, it's you can take the multiple values, but in relation it doesn't support the multi-values. Only it supports the single values, and further dividing of the attributes is also not possible. So that's why attributes must be atomic and it must be single valued here.